Good morning to everyone. We are going to speak about the topic virtual function. What is a virtual function? Suppose before saying virtual function, see what is a polymorphism. So in polymorphism consists of the two types. That is, in polymorphism will be same function name. Function name will be same, but the given activities are from different forms. So polymorphism is of two types: compile time polymorphism, runtime polymorphism. In compile time polymorphism is of two types: operator overloading and function overloading. In this function overloading, function overloading, it has same function name is given, but the parameters are of difference. This everything is handled only in the compile time polymorphism. In runtime polymorphism is a virtual function. So virtual function held only on the runtime during the time. What is binding? Binding refers to the process of converting identifiers such as variables and performance name into addresses. Binding is done for each variable and function. That is, what is going to do is that all the variables are converted to the address. That is, here we are going to use as a pointer variable. Values can be assigned to the pointer variable. If you are assigning the pointer variable, the address of the variable can be assigned to those variables. So such that it is then for process of converting the variables into address. So by using pointer variables and reference variables, we are going to do this job. So binding refers to the two: yearly binding and late binding. So yearly binding means it is done in the compile time. So it can be function overloading and operator overloading. Late binding means it is a virtual function. It is done only by the runtime polymorphism. So what is yearly binding? It is done in compile time. So as the name indicates, compiler directly associate an address to the function call. So in this, while doing that, it is done in the compile time. So at the compile time itself, if we call the function call, the address is associated to that. It replaces the call with the machine language instruction that tells the mainframe to lead to the address of the function. Now late binding runtime polymorphism. In this, the compiler adds code that identifies the kind of object at runtime, then matches the call with the right function definition. This can be held by declaring the virtual functions. Virtual functions in C++. A virtual function, it is also known as a virtual methods, is a member function that is declared within the base class and is redefined overridden by the derived class. So in virtual function, we are declaring the virtual function only in the base class. So in base class, we are declaring one function as a virtual, and from the base class, we are deriving the another class. If we are deriving in the another class, if we redefine the same function, it is virtual function. It does not mean, that is, overriding is avoiding by this. Overriding is avoiding by this. Virtual function ensure that the correct function is called from an object regardless of type of reference or pointer to use the function. So here what we are doing is, for everything we are calling the address of the variable by using the pointer variable. So function call is done by the pointer variable. So this is mainly used in the runtime polymorphism, and the function is in base class. It is declared by the virtual keyword. The resolving of function call is done by the runtime. So using the function keyword, virtual keyword with the base class version of show function. Late binding takes place and derived version of function will be called because base pointer as a derived function. So what we are doing is, suppose in base class we are declaring one function, name it as show function. We are declaring the show function by such as void show, but before declaring the function void show, we are using the virtual keyword. So now virtual void show function we are declaring in the base class. By using the late binding, from the base class we are deriving the derived version. So now what we are doing is the base pointer is derived from the type of the object. We know that it's runtime polymorphism. The call to the function is resolved at runtime depending upon the type of objects. How virtual function works. A base class pointer can point to the object of the base class as well as to the object of the derived class. How we are doing is that in base class we can declare the variables as a pointer variable. So thus it was base class object pointed to the variable as well as to the object of the derived class also. So in this case, using base class, we can call some function which in both classes, then base class function is invoked. So by using this virtual function technique, the same function what we called in the base class function, it can be called in the derived class also. Both the classes we can call, then base class functions can be invoked. But if you want to invoke the derived class function using base class pointer, it can be assumed by defining the function as virtual input class. This is a virtual function support runtime polymorphism. Suppose in derived class function we have to invoke some variables. What we have to do, it can be done only by the base class pointer. So this can be assumed by the function is in the base class. Rules for virtual function. Virtual function cannot be static. It is dynamic method. A virtual function can be friend function of another class. A friend function means different many types of classes, different multiple classes can be used, and we can write one friend function. So like the virtual functions can be used as a friend function. Virtual function should be accessed using the pointer or reference of base class in runtime. So this can be referred only by the pointer variable. The prototype of virtual function should be same in the base as well as derived class. So what we are using as a prototype should be same as in base class and the derived class. There are always defined the base class and overridden in the derived class. It is not mandatory for the derived class. So here overriding technique is avoided. Virtual function is created to avoid the overriding function because we can what we are derived in the virtual base class, we can derive same function redefined in the virtual class. A class may have virtual destructor, but it cannot be have virtual constructor. Working of virtual function, concept of B table and B pointer. It is a virtual table and virtual pointer. If an object of the class is created, then the virtual pointer is inserted as a data member of the class to point to the B table of the class. For each new object created, a new virtual pointer is inserted as a data member of the class. So what we are doing is that here that in an object class is created, after that for every class creation there will be a virtual pointer inserted in the data member. This is why we are creating this pointer to access the data member variables in the table class. Then virtual pointer inserted data members. Irrespective of whether the object is created or not, the class contains the number of static array of function for B table. Cells of this table stores the address of virtual function contained in the class. So in B table, what are the entries are there? That is, in a class we will be having the function member variable everything. So in B table it is address. So this is a pointer to the object B pointer in B table for base class. This is a B table for the derived class. So it has the address of the base version of function 2, function 3 and function 4. Everything first, what are the base class addresses it is having, and in B table in derived class address of the derived versions for the function 2 and 0. This is object of the derived class. Suppose class derived 1 and class derived 2. Suppose 2 are there. So first the base classes will be there. That is base class B1 and base class B2. From base class B1 we are deriving the derived class derived 1, and from base class B2 we are deriving derived 2. So here we will be having virtual pointer for everything. So by using pointer only we are going to call. So B pointer is the B pointer which points to the virtual function for the object. B table will be is the table containing address of the virtual function of B class. So pointer will be calling by that address derived 1 to show the functions in both the variables. One example program, class base. Class base, this is a base class. Here we are declaring that function name is void print and void show. Here what we are doing is void print function. It is assigned as a virtual function by using the virtual keyword. So virtual void print. We are going to print base class, and in another function void show. It is a simple function void show. See how to show these classes. Then class derived public base. From the base class we are deriving another class named derived. Here also we are using the same function name as void printer. Already in base class we derived as a, we mentioned assigned as a virtual void printer. So if we are putting a void print, it does not overload. So here we are printing derived class, and in same thing void show derived we are going to print. So this is, now we are creating object. We are creating pointer. We are creating pointer for the base class. So that is B pointer. For the base class we are creating object as the pointer, and for derived class we are creating object as a D. Then B pointer equal to ampersand T. This means we are assigning the address of the derived class to the pointer. Next, virtual function binder at runtime. So B pointer is equal assigns the print function. So now what is going to do? As soon as the pointer already to the pointer, the address of the derived class is assigned to pointer. So automatically it goes to the print functions and print derived class. It is because derived D pointer B pointer equal to ampersand D. This means base class object is assigned to the derived class. Next is non-virtual function binder at the compile time to show. So this automatically goes to the base class show. So show base class is returned. Limitation. Slower and difficult to debug. So this is a limitation. The function call takes slightly longer due to virtual mechanism and makes it more difficult for the compiler to optimize, because it does not know exactly which function is going to be called at the runtime. Because of this virtual function mechanism, it gets slower because everything pointer and address of the variable is called. So compiler does not know which functions to be called. And another reason to error found in difficult to debug. In a complex system, virtual function can make it little more difficult